Hey everybody, welcome back to another episode of A to Z of Python. Today is the letter R, so we're going to be talking about regular expressions. And this is a topic that is near and dear to my heart because it is one of the more complicated things that you can learn, but it is so valuable and it's really a universal concept. So if you learn it in Python, you can use it in JavaScript or whatever you want to use it in. It's pretty much a common theme throughout most programming languages, so it will be something very beneficial to you uh, going forward. So it's worth learning, and we're going to talk about it today. So before we jump into the nitty gritty here, what I want to do is talk about what regular expressions are designed to do. So let's import the module, which is RE, and that will allow us to access the methods that perform the things that we want to do. And we're going to build a basic regular expression. So the idea is that you have a string. Maybe it's like a string literal, like something that you've just assigned. Maybe it's an input that someone's given you. Maybe it's from a database, or maybe it's from you scraped it off of a web page. It's a paragraph or something like that, or an article. And you want to search through that text to see if there is a particular pattern in there. And if the regular expression matches, if the pattern that you're searching for, say like an email address, you want to know if there's any email addresses in this article that you've read, you can apply the regular expression and it will say, pretty much true or false. Yeah, it's in there. No, it's not in there. And you can even go as far as to find out what characters it spans. You can find out all kinds of stuff. And you can also, if you want to, extract those out from the body of text or the string and put them into some kind of list or something similar for usage somewhere down the road. So you could extract a bunch of things as well as just matching. But first thing I'm going to do is just check for a match. Okay, so we're not extracting anything, we're not saving anything anywhere else. We're just checking to see if a particular pattern exists in a string. And we can do probably the most basic one is re.search, and you'll see that it gives you an option for a pattern, a string, and some flags. Now, we're not going to be using any flags in any of the examples, but they do allow you to modify the behavior of the regular expression, and they are pretty helpful, so you can find those in the documents and decide if you want to use those or not. But the basic application here is to put in a pattern and then tell it what string you want to check. So we're just going to create our own pattern, and it's just going to be simply the letter O, and we're going to give it a string by typing one in, and we're going to put in the word dog. And so what we're saying here is, hey Python, search the string containing the word dog and tell us if the letter O is in there, and it will tell you. So if we just want to print this out so that we can see the results. And it returns what's called a match object. It tells us where it's located and it tells us what it matched. So it matched the letter O. It's essentially the first character, between the first and second character, sorry. And it's pretty straightforward. That's it. So this is a success, and we could confirm that the search term is actually in the string, the pattern is in the string, and that's sort of the most basic fundamental of regular expression. So the reason that I'm starting with this is so that you understand the complexity is in the pattern that you choose. So O is a pretty simple one, but the cases can be almost indecipherably complicated. Unreal how complicated these things can get. And the methods, it's not just a search, there's quite a few depending on the behavior that you want. So our focus today is on the pattern and the methods. And to give you a strong enough foundation to where you can go out and start creating your own for uses in the programs that you're writing. So I've typed some of this up to save some time, and I'm going to show you some of the tokens that we can put in the pattern to alter the behavior of this. And so we could search the letter O, but we can also use brackets and we can put multiple characters in there. And in this case, this would search for all the vowels, so to see if our string contains any vowels. So that could easily be put down here. We could search a range, and in this case, this is A to Z. It is case sensitive, so it's a lowercase a to Z. We can say, are the characters not in there? Okay, so the caret symbol, it means that they're not in there. We can match any character. This is any single character. Okay, so if we want to see if it's got an O followed by anything, you could put O dot, something like that. You got white space characters, non-white space, digits, non-digits, words, non-words, and then you have the ability to modify those with different symbols. So we have the star or the asterisk is to match 0 or more. So it will, if there's 8 A's in a row, it'll match all 8 of them. And that becomes important when you're matching things that you don't know what they're going to be. Say like an email address, you don't know how many characters are in the first part of the email address. Well, you might want to match as many as there are, so then you can match the @ symbol next. So it'll just consume all of those and then go to the next step. There's the plus, which means it must be at least 1 or more. And then we can put an actual exact limit, so exactly 5 of the letter A in a row, 5 or more, okay, or 2 to 6. And these are just some of the few of the many different things that you can do inside your pattern to build very complex patterns for your regular expressions. And then we showed you the search method already, but there are quite a few of those too. And here they are. So we have search, which we've already done, which is, it follows the pattern string flag. So what pattern do you want to search for, and what string do you want to search in? And this will return either the match object like we saw earlier, which contains the location and the matching text, the matching pattern, and it can also return none. Okay, so that's pretty cool. And that can be kind of nice because if it returns none, you can use it in an if statement, for example. We can use dot match, and the match is the same as search. It just looks for the pattern, but it must start from the beginning of the string. So a match would not match the letter O here because it's not the first character in the string. It has to be at the beginning. There's full match, which we will show an example of, which consumes the entire string itself. So it would have to be, if I had dog as the pattern, this would match if this was full match, but if there was an A in front, it would not match because it does not consume the whole string. There's characters on the front or the back, and that would not work. And then there's find all, which will give you back a list. So if you want to actually retrieve the results, you're searching a web page for phone numbers, for example, it'll actually find all the phone numbers and put them in a list for you. And it will do non-overlapping matches, meaning if somehow there's two email addresses stuck together in a weird kind of typo, it's not going to return 2 separate results. It may return 1 or none, but they have to be non-overlapping. And then there's find iter, which returns a match object like we saw before, but one that's actually iterable. So almost like a list, I guess you could say, of match objects is kind of how it behaves. It's an iterable object. And then there's sub, which is another good one, and this allows us to actually use a replacement string. So we could say search for dog in the text and replace it with cat, whatever you want to do. And so that's pretty helpful if you want to modify, almost like a find and replace function, essentially is what it does, but allows you to be very specific. So the idea here is that a lot of times you don't know what you're looking for. Maybe the phone numbers take different formats, okay? So you want to be able to capture any format, something like that, or an email address, which could be all different formats. It could be different domains, different lengths, things like that, and you want to capture them all. So let's just dive in now that we've kind of gotten over that. I know it took a while, and try to show you some examples. So let's do that. We'll start with this string here. And again, I'm going to copy and paste as much as I can to save some time. So we have a string that says, who wants to go to the park if it rains? Okay, it's probably nobody, but that's the question. And we can do something like print re.search. We can choose a pattern, so let's choose an S. And we put the string in. The string is actually named S, okay, so that might be a little confusing. We can name this question, okay, something like that. That way it's a little more intuitive. There you go. So this is the search pattern. This is the string, and we can run this, and it finds a match S, okay, so that's a success, and it's saying that it finds it in the span of 8 to 9, so that's right here. Now there are 2 S's, okay, but search does not tell you how many. It literally just says, does it exist? Okay, and it does, and it finds the first match of that, and it stops. Okay, so this is more like, is it in there or is it not? I don't care how many there are. I just want to know if this exists at all. And we also have print. We'll do re.match. Okay, and this is going to be the same thing. So S question, and we'll run that. And it says match the S in this string, and it says none. Okay, so if we remember from match, okay, it only matches from the beginning of the string, and so S is not the very first character here, so we're going to get a failure, and it's going to return none. Okay, so can be helpful. You want to know if it starts with something in particular. If the first, you want to see if it's a bulleted list that's numbered. Okay, so does it start with a number and a period? Okay, so that would be an example of how you might want to check that. All right, so then we have, we'll do another one. We'll do re.sub, and it's asking for the pattern, which will be S. The replacement, which would be, we'll just do a $sign, okay, and the string, and we'll do question. And we have optional count, so we can do it as many times as we want. If it's defaulted to 0, which it is, it will do all of them. We could say just change the first one or change the second one or whatever. So we're going to go ahead and leave it like it is and run that. And you'll see that it's replaced the S's with $signs. Okay, so that's how the sub function works. And that's pretty much it for the basics. And these all you can just apply across the board to see how they work. But that's to help give you an idea of what the syntax looks like. It's pattern usually, and then string, and sometimes there's other stuff in there. And that's it for those 3. So let's go on to maybe a more complicated example. So let's say that we want to look at, let's see, let's do the email checking next. Okay, so what I've done is I've copied a bit of text from a Wikipedia article on email addresses, and that's right here. And it talks about how they're constructed. So there's lots of characters and sentences, and it's just a long thing. There's bits and pieces of email addresses all throughout this, but only one actual full email address example. And so what I want to do is go ahead, and I've named that file that I saved, I named it emails.txt. So what we're going to do is open that up. You're going to do open emails.txt to read. And that may be optional in Python 3.5, but we'll put it in there. I don't know. And do r equals f.read. Okay, so we're opening the file, and then we're loading the contents into R. So R is now a string that contains the entire contents of the emails.txt. And what I'm going to do is I'm going to do regular matches equals re.findAll. Okay, so we're going to do the findAll method, which will return a list of strings or tuples even, depending on the way that you use it. So we're going to do findAll, and then we're going to put in a much more complex example because we want to find any email address. And this is something that I'm going to type out and try to talk about it, but you could just Google this and find one that works and copy and paste it in. I wouldn't recommend for these general examples to try and reinvent the wheel here because someone has put a lot of time in making sure that it matches all the different types of email addresses. So the way that this will work is we're going to start with an R and then a single quotes there, and this will begin this lengthy pattern that we're going to use. And the way that we're going to type this out is we're going to put this into a parentheses because we're going to have a whole bunch of stuff in here, and we're going to start with the match any of these characters list thing here. So we're going to go ahead and put A to Z. Okay, so the first thing we're doing is matching the first part of the email address, which could be name dot something, you know, uppercase, lowercase letters, underscores, or dashes. Those are all common characters. So A to Z. We also want to match uppercase A to Z. All right, so this will match any lowercase or uppercase letter in the alphabet. We also may want to match 0 through 9. Okay. And we may want to do an underscore, a dot, a plus even, and a dash. And this is the first piece. So what it's saying is match any of these characters in the first part. So it has to have these in here and only these in here. And then we're going to say plus the @ symbol. So also match an @. So it can be any of these characters followed by the @ symbol. All right. Plus we need, let's see, another series of A to Z, and 0 to 9, and maybe a dash, something like that. Okay. And that will match the part after the first part. So this is going to be the domain, and in the domain you may have a dash, but you will not likely have a plus or an underscore, things like that. And then we will need to match the dot, so we'll do plus. And in order to match a literal period, not the dot up here, which means match any character, so we just put the dot there, it's going to match any character, but we want to match an actual period, so we have to escape out with the backslash, put a period, so that will match literally the period itself, so the dot and the .com, and then we'll do another A to Z, another capital A to Z, and another 0 to 9 and dash. So we'll do 0 to 9 dash, close that off. And I want to make sure that the domain, the .com or .net or .ru or whatever it is at least 2 characters long. And so what I'll do is I'll use these curly braces, and I'll put, let's see, curly brace 2 comma, which means 2 or more. Close that off, and then we need to put our string, which is R, if you remember from up here. I read that in. So there you go. So that's what I'm talking about when I say that these can get infinitely more complicated than just matching a single letter. So what we get here is that we can match any of these characters. Okay, so exclusively the email address can contain these characters plus an @ symbol followed by these characters plus a dot followed by these characters, at least 2 of them. And if we do that correctly, we should get a result. And then there's also the find iter. Okay, so find all, like we set up here, is going to find all of them and put them in a list. The find iter will return an iterable object. So I'm going to do iter matches equals re.find iter, and I'm going to copy this pattern over in that string. All right, so I want to do the same search here, but I want to show you the difference between just doing find all and find iter. Okay, so we're going to print the regular matches first, and then I'm going to do for item in regular matches print I, so we can print out the whole thing, and then we'll print them one by one so you can see the behavior there. And then I'm going to do print iter matches, and I'm going to do for I and iter matches print I. And I'm going to run this. So what I'm going to do is, yeah, everything looks good there. Let's try it. And okay, so it found an email address called john.smith@example.com. So you can see that that's in a list. And then when we iterate over the list, we just get each individual item. And then we print out the iter matches here, right here. And that shows that it's an object, an iterable object, match object. And if we iterate over it and print it out, we see the match object like we saw before when we matched an O and dog. And so let me go into the text file, and I'll go ahead and add, I'll just do steve@msn.com. So we'll add a second email address in there, and we'll run it again. And now you see that it does in fact create a list. And these are very different email addresses, right? There's different, lengths and different characters, but it works just the same. And it iterates over them. And then this time it iterates again, and it shows the different locations and the matches there. So the confusing part for most people isn't what the methods do, it's constructing the pattern itself. So this is like really cryptic looking if you're not used to it. And this is, I'm not going to lie, I just pretty much stole this from the internet. There was a website that had it listed out. It seemed to be pretty effective at matching email addresses, and I don't have to, again, reinvent the wheel. But I did add this part at the end, the brackets with the 2, because I wanted to make sure that we didn't have a single letter domain, so like .b or something. That I don't know of any that are single letters. There may be, but I know there are some that are 2 and longer, and so I added that in myself, and it works pretty good. So that is an example of reading from a file, checking and actually extracting the matches with both find all and find iter. And a lot of people will argue that find iter is better because you can actually, from this object, you can call another method and print just the contents of the match as well. So you can take a match object and print out any of these individual variables here on their own. So it contains more information than just doing the straight up list version, but it's easy enough to call just this part of it. So you have the extra info if you need it. And so kind of to future-proof, find iter is a little bit more robust. And it can do the same things but more. So a lot of people will opt for this over this. So there you go. So we've got that down. I want to go over one more example, then we'll be done with this. And I'm going to take one that's saved the most complicated for last. And this is one where we will write a small program that will allow a user to change their password. So they're going to enter in a password, and we're going to check to see if it meets our criteria that we set. So I'm going to paste in the requirements for the password. All right, so it says for the password complexity check, we're going to ask them for a password. It has to be 8 characters long. It has to have a capital letter, a number, and a special character. Okay, so don't need that. So that's the minimum requirements. Okay, and so that will help you understand when we are constructing this pattern what we're actually looking for. And so I'm going to show you 2 new techniques. So far what we've been doing is we've been creating a pattern in the method call itself. So we've been doing, re.search, pattern, and string. Well, as you saw, the pattern was a bit unwieldy. It was very long and very complicated. And we don't want to have to keep retyping that over and over and over again. So what we can do is we can actually compile the pattern into an object, like a pattern object, and we can use that throughout the rest of our program. So we can do it once, and then we can use it over and over again. And you would see something like that if you're doing a URL, for example, for a request. You may need to pass a very lengthy URL into a function call repeatedly, and you don't want to keep typing that URL in. You just set it as a variable once and use the variable going forward, and that's essentially what we'll be doing. So what I'm going to do is do pattern equals re.compile, and inside this I'm going to put the pattern for our regular expression, and it's going to start the same way. So R with the single quotes, and this is going to be a very, very complex pattern, and I'm going to do my best to explain what's going on without taking too long. So I'm going to go ahead and think, okay, what do we have to check for first? Well, we want to check that there's a capital letter first, okay, and then we want to check that there's lowercase letters. We want to check that there's numbers, and we want to check that there's a special character. So what we're going to do is we're going to create groups within the pattern that are checked one by one, and then we'll check the whole thing. Okay, so we can start with the set of parentheses here, and we're going to do something that looks like this. This would be a question mark equals dot star, and then we're going to do the list here, and it's going to be capital A to capital Z. And what this does, this pattern, is what's called a positive look ahead. Okay, so let's see. I try to think of the best way to explain this. This bit of code right here tells Python to look through the string, and it essentially matches the whole string. It takes the whole string and goes one by one back through the string to look for an A to a Z, anything between A to Z. And then if it finds a match, it just lets go and moves on. It doesn't have any effect on what happens next. It just verifies that it is in fact in the string itself, and it's just a check. Okay, so this whatever we put in next will be unaffected by this, but if this cannot pass, then we will not have a successful password change. Okay, so we can do a similar positive look ahead for each individual item that we want, and then we can go, and once we're certain that each of the criteria are met, we'll check for length and then make sure that there's no unacceptable characters or whatever inside of the password. So we'll do another set of parentheses, and we'll do the same thing. So question equals dot star. So it's going to basically be it's called greedy. It consumes the whole thing, and then it goes through it and says, okay, are these in here? And we're going to do lowercase a to lowercase z. And so now we're matching. Is there an uppercase and at least one uppercase and at least one lowercase letter in there? And then we'll go to the same thing again. All right, dot star, and we'll put in the \d, which, if we recall, here is a digit. Okay, so numerical digit in there, so that's good. So now we know that there's going to be one of those. There we go. And we want to check, look ahead and see if there is a special character. Okay, so again, dot star, and we're going to do our little brackets here, and we're going to put in everything that we can think of as a special character. So that's good. At symbol, maybe those. And I mean, pretty much you could just rake your finger across the the keyboard and pick out a bunch of characters. We want to make sure these are characters that are acceptable in a password. So, and probably a dot would be sufficient too. So, there's a duplicate there. And okay, so there you go. So any of these special characters would be fine, and you can put as many or as few as you want, but pick the ones that are likely to be chosen. And then that's that. Okay, so there we go. So I know this is getting kind of crazy, but what we have here are 4 positive look ahead statements, and it will go one by one through the string and verify that we have a capital letter, a lowercase letter, a digit, and a special character. So assuming that the 4 of those criteria are met, we still need to make sure that it is 8 characters or more, and that it doesn't have any prohibited characters in there, okay, like a space or something like that. So we need to create one more, and this is not a positive look ahead. This is just this is the first part of the regular expression that actually consumes the string and doesn't skip once it's verified. Okay, so this is the actual work part of this expression, and what we need to do is put everything in there. So A to Z, so capital, lowercase, the digit, and then these special characters. Okay, here. So we get that, and there you go. And we need to make sure that it's 8 or more. Okay, there you go. So I think that should work. Okay, so one more time, we have 4 positive look ahead statements, and that's what this does. And you can look these up. I'll show you a tool that really makes it easier to understand. And it checks for each one, releasing the string after each one so that the next one has a fresh string to work with. They say 1, 2, 3, 4, and then this consumes it goes letter by letter in the string to make sure that it includes only these characters and the symbols and numbers. Okay, so, and that it's 8 or more in length. Okay, so now we've covered that. Again, that's the most complicated part of this. It's saved into the pattern, which is an object that can be passed to either any of these methods, or it has methods of its own. And I'm going to show you how that works. So generally, what we do, let's go ahead and do while true. So we're going to create a loop, and we're going to ask for input. So we're going to put user pass equals input. I'm going to put enter a secure password. I'm going to assume that you've already explained to them somewhere else in the program what secure password means, okay, so that they know the requirements. And I'm going to do if. Now what you might be tempted to do is do re.fullMatch and then put your pattern, which is now pattern, okay, because we've compiled that in. and your string, which would be user pass. Okay, and you'd say if that, okay, and that would be a proper way to do it, and we could do print, you know, password changed, and then we could break out. So what this is doing here is it's saying, okay, until this breaks out, so until they give us a valid password, ask them for a secure password and check and make sure that the inputted user pass meets this requirement here, okay, so that that pattern matches. And this is the standard way to do it, but what I want to show you is that in the newer versions of Python, the pattern itself can be called, and we cannot have to pass pattern in, so we can actually get rid of that and just make this pattern dot full match. Okay, and that is exactly the same, you know, as the other way around, but it's a little bit more streamlined. We don't have to pass in pattern. We just call the method full match on that, which is pretty cool. So that's the preferred way to do it going forward. So that's what I'm showing you now, is that you can do it either way, but you want to actually call the full match method on the compiled object and then just pass it in the string itself. Now, one thing that I want to talk about, and if this confuses you, don't worry, but a lot of times you'll see regular expressions with the caret symbol at the beginning and a $ at the end. Okay, and this is super common. You're going to see this in all of these basic examples like this of finding a password, or when there's a user input, you want to make sure there's no leading or trailing spaces, whatever it is. And these are I guess assertions that tell me that the string starts here and ends here, and that will essentially tell you that this password is consumed completely by this regular expression. So it's kind of hard to explain, but essentially this is the start of the string and that's the stop of the string, and it assures that you are getting the entire string. So you want to start from the beginning and read all the way to the end to make sure, like if the word dog is also in the word dogma, for example, well, you might match the word dog within dogma, but it's not the same word. And so you want to make sure that you look at the entire string. You can put the caret symbol and the $ at the end, and dog would not match with dogma because it doesn't consume the whole string, okay? And that's very common. But full match, which is a relatively new method in, I think, Python 3.4, handles this for you on the back end. So we can actually get rid of these, okay? And the full match means whatever we are checking here must be valid across the entire string, okay? It must match the entire string. So no, oh, we found these characters, but they're in the middle of the string, or they're at the beginning or the end. No, this is valid across the entire string, and that's what full match does for you. And you're going to see in every example that you look, the caret symbol and the $, and you don't really need those anymore if you do it this way. And that's a purposeful change to get rid of that, so that you don't have to deal with it. But a lot of people don't like it because they're not used to it and they think it's confusing, but it's not. This is the way it's going forward, so try and do it this way if you can. So, all right. So now that we've kind of, again, I'm trying not to deviate too much, but hopefully if that makes sense. If not, that's okay. You can do it either way. And then we'll do else here. So if we successfully match, print the password changed and break out. Otherwise, we need to print not secure. We'll just put password not secure enough. Okay. And we'll go ahead and run that. and we'll put in a password like Sally. Okay. It says the password's not secure enough, so let's do internet1 exclamation point. That's got a capital I, it's got a number, it's got a special character, and it's more than 8 long. And there you go. So this is password changed. So that shows us that we are successfully checking for each one of these individually and then validating the whole string. And if it passes all those criteria, we're successful. And then I want to show you, okay, so this isn't really making much use of this object. It's only using it once pretty much. It could use it more. I guess it used it twice, but it wouldn't have been any shorter to just, we could have taken this and put it down here. But if we get rid of this and we bring in a list of passwords, which I'm going to copy and paste in here. So let's say we have a list of passwords and we want to know, do these passwords meet the criteria for our pattern? Okay, so we're checking a password list against our pattern, and we can do for password in password list. We do if pattern dot match password, and we'll do print password pass, as in like it passes the test. And then we can do else, do print password fail. Okay, so what we're doing is we're saying iterate over this list. So for each password, which would be each individual string in this password list, do a pattern, okay, on the compiled pattern, match it, okay, match it with the password. So we're saying match, this is our string, it goes in here, and we're doing a match. And if you recall, a match is the same as a search, but it only matches from the start of the string. So that means that these passwords must begin with something that will match here. Okay, so pass or fail, and let's run this, and we'll see some of these meet the qualifications, some of them do not. So we'll run, and we'll see that this one fails because there's no special character. This one passes. This one fails for lack of capital letter. This one fails for a lack of a capital letter, and this one passes. So this is an example of iterating over a list and using the object, the pattern object, over and over again. And that is pretty much everything that I have for you. I know it's a lot. I tried to keep it short and not get too distracted and drone on, but this is like super complicated stuff, but it's very powerful. And I want to show you a tool. There's many. You can Google regular expression tester or checker, and this is regex101.com, and I choose Python as the language, and we can go in here and we can paste in, so we can go back to our program and copy the contents of our pattern, paste it over, and it tells you what each section does over here on the right. Okay, so it helps you learn, and then you can put in something. So you can put in a password, and it says no match. So we can put in password 1 exclamation point, and it matches. Okay, so it tells you how many steps it goes through in case you have a runaway expression that just loops forever and goes on. And it can tell you your test string. So if you have a series of passwords, or you have a string that you know should pass or should fail, you can test them on here and see what each item does. Okay, and then you can tweak this until it starts passing your test. So these tools are infinitely helpful, and this site's a little bit slow, so maybe it'll load up, maybe it won't. But generally, these sites will have a library of sorts, which will contain a bunch of pre-done patterns for you for matching URLs, which is common, matching email addresses or phone numbers, which are common. And some of them are pretty good, some of them, you know, so-so, but so I can put like phone number So here's one, JavaScript, and let's see. There's a Python, so phone number extraction. Here's one that they claim will extract phone numbers for you. All right, so you can copy this out and paste it in and see if it works for you. But there's many, and some for different languages. You can filter over here down to just Python. Okay, Brazilian phone numbers. This one looks pretty basic here, right? This one looks really complicated, but it handles international formats. So you get the idea. And again, I don't want you to spend like forever doing these basic things that have already been done. You can steal this code and use it in your program just fine. But for those times where you need to make your own, it helps to know. So that's all I have for the video. Hopefully you enjoyed it and learned something. If you have any questions, leave a comment. And if you enjoyed the video, please subscribe. Thanks a lot.